So I'm going to teach our last lesson of calculus by not really teaching the full lesson, okay? If you want to know where this area formula for the trapezoid comes from, you know, after you're done with your IA and after you know everything else for IB, then this is going to be the last thing that I'm going to show you, okay? So anyway, so let's kind of go back a little bit. So let's just say we have a function, something like this, right? And I tell you that this function right here is f of x is equal to x squared. And I ask you to find the area. I think we've done this so much. If I ask you to find the area of under this trapezoid from 0 to 4, right? We know that we use to find the area of a trapezoid, we use yes, integration. Okay, so we're going to use integration or antiderivative. You put the lower bound, the upper bound. So from 0 to 4, you put in the function, which is x squared, and then dx, and then you plug it into your calculator. Okay. At this point, you should be an expert on putting that into the calculator, math, integration. And you get a number that looks like this. And if you're like, hey, I don't want it like that, I want it as a fraction, you hit math, hit option number 1, and it changes it into a fraction for you. Ta-da! So your final answer is 64 over 3. Okay, good. So what if you don't have the actual equation? Like here, you see how we're given x squared. What if you don't have that? You just have a bunch of like points, right? So like if I say, instead of having all of this, I have this point right here is going to be like 1 comma 1. And then I have this point right here is going to be, if it'll feel like writing, is going to be 2 comma 4, so on and so forth, right? I just have a whole bunch of points. How do you find the area under the trapezoid or area under the curve if you're not given this function? Okay, so today's lesson is on the trapezoidal rule. This is in your formula booklet. You do not need to memorize this. Bam! So here's the trapezoidal rule, okay? So I'm going to tell you what all of this means. Like I said, if you want to know where this is coming from and you've done literally every single other thing that I've asked you to do, and you have 20 minutes literally to do nothing, then come see me and I'll teach it to you. But this is how you use the formula. All right, so I want you to skip down to this problem right here. So for example, we're estimating the area under the curve, and this is our x values, these are our y values. So the first thing we're going to do is we're going to go ahead and, like the formula tells us, we're going to put a little integration sign. So let's go ahead and do that. And then the a is where we start, so we are starting at 1 and we are ending at 6. Okay, so from 1 to 6, so it's going to be for y dx, because we don't know what the function actually is, so we're going to just call it y. And we're going to say that this is about, right? You're going to put 1/2. To find your h, right, they give you a formula. So you do b, which is 6, the highest number, minus a, which is your lowest number. So I'm going to call this a and this is b. So 6 minus 1 divided by n. This right here is the number of trapezoids that you're splitting this into. So how do you figure that out? Okay, very simple. You just do 6 minus 1, right, is going to be 5. So there are 5 trapezoids. So 6 minus 1 is 5, divided by 5 is equal to 1, which makes sense, right? This height from 1 to 2 is 1. So the height is 1. From here to here is 1, 1, 1, and 1, right? So our h is going to be 1. So I'm going to do 1/2 of 1. And then I'm going to open up double parentheses right here. And so now y0, let me just go ahead and erase all of this stuff right here. So our y0 is going to be this first number right here. So I'm going to put 1.5 there. And then our yn, which is the last term, here's our yn. So I'm going to put 0.9. I put a plus sign between it, 0.9. And then I'm going to go ahead and close parentheses, put a plus sign. And then I'm going to continue my function right here on the bottom, 2 parentheses, and I'm going to write down all the rest of it. So y1, y2, y3, and y4. 4. So I'm going to put 2.7 plus 1.0 plus 0.8 plus 0.6. Okay, let's close that and close the bigger one that I opened here. And then I go ahead plug that into my calculator. So when I plug that whole thing into my calculator, I get that my area is going to be about 6.3. That's it. All right, so let's try a couple of problems and hopefully this will solidify in your head. So find the area of the three trapezia shown, right? So we know that n is equal to 3. All right, so now to find the height. So this is going up by 1 here. So my height of my trapezoid is 1. And then I'm going to open up another double parentheses right here. I'm going to put my first term, which is 1, plus my last term, which is 1 over 16. Close that parentheses, put a plus sign 2 times, and I'm going to write down everything else, which is just 1/4 plus 1 over 9, close, close. I'm going to take this whole thing and plug it into my calculator. So I just did that. 1/2 times 1 times 1 plus 1/16 plus 2 times 1/4 plus 1/9. Hit enter, and I get 257 over 288. So the area, the answer of part A, is going to be 257 over 288. Let me just make sure that that is correct. Yes. Good. That should be hopefully pretty straightforward. Then it says use your graphing calculator, right, to find the integration. Again, I think we've done definite integrals enough. You just hit enter and you get 0.75. So for part B, you should have 0.75 as our answer. All right. For part C, find the percentage error. Okay, so let's look up the formula for percentage error. All right, so here it is. So you take the absolute value of the exact value minus the approximate value divided by the exact value times 100%. So now let me actually do it, right? So I'm going to take my value that I'm doing absolute value, and I'm going to take my value that I got from part A, which is the approximate value, which is 257 over 288 minus my exact value, right? This is what my calculator gave me, which is 0.75. And I'm going to divide that by the exact value, which again is 0.75. So I'm going to put that on the bottom. And then I'm going to multiply this whole thing by 100. All right, I feel it's a good idea to spend some time going over how do you get like a double fraction in the calculator and how do you get these absolute value. So first thing, hit math, go over to num, go to option number 1, which is ABS. Okay, so now I have this line right here. So now I have a fraction and then I have another fraction within that. So let's go ahead and hit alpha y equals option number 1. So this is going to give us where I can put my first fraction in. And then after I did that, I went ahead and hit alpha y equals again. And now it lets me put this 0.75 on the bottom, so 0.75. But I need to go back on the top and insert this minus 0.75. So I'm going to do that. So I'm going to go up to the top, put minus 0.75. And then I'm going to go outside of my absolute value, which is this right here. And I'm going to put times 100. And hit enter, and I'm going to get my answer of about, yeah, this says percentage error, so I'm going to round this to about 19%. So my percentage error is about 19%. Okay, that's the answer for the first one. All right, second question. So I'm starting out the same way. So find the area of the three trapezia. So my n again is 3. My height is 1, right? From this distance to this distance, that's all 1. So the height of my trapezoid is going to be 1. And then I'm putting my first number. So my first number here, if I look, this number right here is at 1 because it's going by 1s, 2, 3, 4, and 5, right? So this one right here, the height is going to be 1. My last height, this one right here, is going to be, it looks like 16. If I go across right here, right, that's 16. So I'm going to do plus 16, and then I'm going to close that, put plus 2 times, and I'm going to put everything else, right? So this number right here is 4 plus this number right here is 9. So I'm going to close that, and I'm going to go ahead and take that whole thing right there and plug that into the calculator. When I plug it into my calculator, I get 43 over 2. So my area is approximately 43 over 2 units. Then it says using my graphing calculator. So I'm going to go ahead and take my calculator, math, option number 9. I'm going to go from 1 to 4, plug in my function, which is x squared dx, hit enter, and I get that this number is about 21. Well, this is exactly 21, right? So now I'm going to use my percentage error again. So for my percentage error, absolute value times 100. So I'm putting a fraction bar here. I'm putting the number that I got right here, which is 43 over 2. You could also put 21.5 minus 21 all over the exact, which is 21. Take this whole thing, plug it into the calculator, and when I did that, I got that this is about 2.38%. All right, so that is my percentage error. Okay, so if I use an approximate value, that is the 21.5 minus the exact value, which is 21. I think you're starting to get the hint of this. Now we're going to go through some IB questions. All right, so here I'm going to go ahead and put my formula again, which is 1/2 times my height here is 5, right? This is jumping by 5. So I'm going to put a 5 over here. I'm going to open up my double parentheses. My first term is 115, right? Here's my y0, which is 115, plus my last term is 67. So I'm going to put that there. And then I'm going to close those parentheses, plus 2 times, and I'm going to write all the rest of these numbers right here. So it's going to be 105 plus 90 plus 75 plus 72 plus 69. Plug all of that into the calculator. And when I hit enter in the calculator, I get 2510. So my area is about 2510, and I'm looking for, this is in meters squared, so 2510 meters squared is the area. Okay, so that is for part A. For part B, it says we're looking for the total cost of excavation. So for part B, it's going to be 2510, right, which is what we just figured out for part A. And we are going to take that number and multiply it by 12, because the cost of excavating is $12 per meters cubed. So we're going to do 2510 times 12. And if I take that and plug it into my calculator, I get $30,120. $30,120 is my answer for part B. Okay. For question number 4, we're starting the same exact way. So our formula for area is 1/2 times our height. So here this is increasing by from 1 to 1.8 to 2.6. So this is going up by 0.8. So my height is going to be 0.8. I'm going to open up my double parentheses, and then I'm going to go ahead and put in the first term. So my first term is 18. My last term is 50. So I'm going to do 18 plus 50, close that, plus 2 times. I'm going to write down everything else. 19.28, 23.12, so 19.28 plus 23.12, plus, I'm going to continue it right here, 29.52 plus 38.48. Let's close that and close that. And when you plug this into the calculator, you're going to get that the area is about 115.52 units. And this is area, so it's going to be units squared. Okay, so that is, and it says round your answer to 2 decimal places, so that's why I went 0.52. Perfect. Next thing it's asking us to do is to write an integral, right? So integral looks something like this. That represents the area that's shaded. So the shaded region, again, starts at the number 1, and it ends at the number 5. So I'm going to go ahead and do that. Starts at 1, ends at 5. I'm going to write down my function, which is right here. They gave it to us. So I'm going to write 2x squared minus 4x plus 20 dx, because that's my variable. This is a simple calculator question. When you plug that into your calculator, you get this. I'm going to hit math frac. Math frac, option number 1, hit enter, and I get 344 over 3 units squared. So let's write that down. 344 over 3 units squared. Okay, that's the integral that represents the area. Part C says find, oh, my bad. I kind of combined part B and part C together. So this first part right here is the answer for part B. This second part right here is the answer for part C. Okay. And then it says for part D, it says now find the percentage error. So remember, it's VA, which is the approximate, minus the exact over the exact. Close that, times 100. So now I just need to plug these stuff in. So my estimated answer is going to be what I got here, 115.52. So I'm going to write that down. So absolute value of 115.52 minus my exact is the one that I just found right now, which is 344 over 3. And this is all over. And I'm going to put the same exact value on the bottom, 344 over 3. Close that, absolute value times 100. And this is, again, something that you can take and put into the calculator. And this gives you about 0. And it says estimation part A. So 0.744% is what I got when I plugged it into my calculator. Okay. All right. So next and last question. This question looks crazy. So I'm finding part A. This is 13 points. First thing I'm going to do is find the derivative. So I think we've done derivative enough that we can kind of do this in our head right now, right? Take this exponent, multiply it by this number right here. So I'm going to get negative 0.06, and that's going to be, take minus 1, so that's going to be x squared. So that's the first part, and then I'm going to do the same thing here. 2 times 0.24 is 0.48x, right? 2 minus 1 is 1. And then this, that's it, right? So I just found the derivative. So this is my answer to part A. Okay, not too bad. Then it says find the maximum height. So remember, to find the max or the min, we need to set this equal to 0. So we're going to take negative 0.06 x squared plus 0.48x, and we're going to set it equal to 0. So when I plugged it into my calculator, right, first thing, right, this goes under y1. The second part, which is 0, goes under y2. I'm going to hit graph, and I get something that looks like this. And I'm looking to see the maximum height. So this is one intersection right at 0, and this is a second intersection. So I'm going to hit second and second trace. Option number 5 is intersection. I think we've done this so much over the last four lessons in calculus that this is kind of hopefully second nature, but if not, then we could definitely practice this more. But you just hit enter, enter, enter. So this is telling us that x is equal to 8. Okay, so our x is going to equal 8. And so now they want us to find the maximum height. So to do that, I'm going to go to my calculator and I'm going to look second graph, and I'm looking for what my y is at 8, right? So my y at 8 is 0. All right, so that is my maximum height, but that is for the derivative. I need to take my x equals 8 and plug it back into my original function. So my original function is what I had up here, right? See this? So this is where I want to plug in my 8 into. And when you do that, you're going to get 5.12. So I'm going to take, once I plug in the 8, my y is equal to 5.12 meters, right? And again, where did I get that from? I got that by plugging it into my original function, which is right here. So I went right here, wherever the x is, and I plugged in my 8. And then when you do that, I just want to show this to you for sure. So I went ahead and plugged in my original, and now I'm going to hit second graph, and I'm looking for the number across from 8, which is where I'm getting my 5.12 from. So now I'm going to write that down, right? So the maximum height is going to be at 5.12. I want to make sure that I also put units, so that's going to be in meters, okay? So by doing part A, we've just secured 6 points, okay, out of our 13. Now let's go ahead and do B. So they're telling us that when x equals 6, right? Here's where x is 4, here's where x is 8. So that means that this right here is going to be where x is equal to 6, okay? It's telling me that the height of the curve is 4.32. So this one right here, the height is 4.32. And then it tells me when x is 10, so this part right here, forgive the not straight line, that's 10, then the height is going to be 4. So this height is going to be 4. Okay, so all I'm doing is labeling it. They're also telling me that point A has coordinates of 4 comma 2.56. So at 4, this height is going to be 2.56. And they're telling me that point D, which is this one right here, is going to be 12 comma 0. So my height is going to be 0. I've also figured out that the maximum height of curved arch ABCD, which is this right here, the maximum height, we just figured out was 5.12 meters. Okay, so good. So now we have all of the numbers that we need to go ahead and using the trapezoidal rule with 4 subintervals. So they're telling us that our uh, there are 4 trapezoids. Estimate the cross-sectional arch. So I'm going to go back to my formula for trapezoidal rule, and I'm going to look at this part right here where it says h is equal to b minus a times n. I said times n, but I meant divided by n. Okay, so now I'm going to go ahead and plug these numbers in. So I have that the maximum of, you see this arch right here? The maximum value, the b, is 12. So I'm going to go ahead and put 12 here, minus the smallest number here is a, which is 4. So 12 minus 4 divided by, and they're telling us that there are 4, remember what they told us? That there are 4 subintervals. So I'm going to go ahead and put that my n, my number of trapezoids, is going to be 4. You could see them right here, right? That's 1 trapezoid, 2, 3, and 4. Okay, so there are 4 trapezoids. So now I'm going to go ahead and evaluate this to find out my h. 12 minus 4 is 8. 8 divided by 4 is 2. So my h is 2, which makes sense, right? This is 2, 2, 2, 2. Perfect. We're off to a good start. So we're going to use the area of a trapezoid, the trapezoidal rule. So we're going to do 1/2 times my h, which is 2. Open up my double parentheses. I'm going to do my first number, which is 2.56. My last number, which is 0. Add them together. 2.56. What is that? 2.56 plus 0 plus 2 times, I'm going to write down all the other numbers, all of these. So that's going to be 4.32 plus 5.12 plus 4. Close that, plug all of that into the calculator, hit enter. And when I do that, I'm going to get 29.44. Okay, so meters squared. So this is about 29.44 meters squared. So good. So this answer is going to be 29.44 meters squared. All right. Next thing, it says write down the integral which can be used to find the cross-sectional area under the curved arch, right? So we're going to go ahead and put our integral. Where is it that we start? We start at 4 and we wind up at 12. So let's go ahead and write that down. So starts at 4, ends at 12. We're almost done. We're going to write down the function which they gave us, which is negative 0.02 x to the third plus 0.24 x squared, and then we have to put dx. So you take this whole thing, that's our answer for part CI, so that whole thing. And then now it says evaluate it, right? So you just take it, plug it into the calculator, and you're going to get that the area under the curved arch is about 30.7. And since this is area, this is going to be meters squared. Okay, great job. Less than 30 minutes. Last lesson of calculus and formally the year. All right, great job. Job.